Hello and welcome to another exciting episode of Introduction to Algebra with me, Nathan Sampath. And today we're going to be solving two-step equations. Well, to start, we're going to have to remind you about what a variable is. A variable is a letter from any alphabet. So it can be A, it can be X, it can be theta, but theta is Greek, so we don't need to know that. And the primary variable we use for our equations is X. And what we can do with variables is assign a number to them. So I can say that X is equal to 1. Now, anytime we work with it, X will then be 1. So if I say 4 minus X, that's 4 minus 1, which is equal to 3. Pretty simple, right?
Yes.
And now, another part of equations are just basic numbers. And we can call those numbers constants. And we call them constant because, well, they stay constant. 16 in an equation will always equal 16, nonetheless of what happens in other parts of the equation. So there are constants and there are variables. Now, with all that background out of the way, we can start solving two-step equations. So for our example, we'll say 4x plus 2 is equal to 10. Okay, so right now we want to solve for x, and x doesn't have any number assignment to it right now because no one's given it a number, and that's what we're trying to solve for. So first we should subtract the constant because it's easier to subtract the constants first than work with whatever is multiplied to the x. So we would subtract the constant from both sides to keep the equations equal. So we'll subtract 2 from the left side and subtract 2 from the right side. This way we get 4x on the left and 8 on the right, while also keeping both sides equal. Now, we have to get the 4 away from the x, but we cannot simply subtract the 4 because it is multiplied to the x. So what we do here is, we would divide the 4 because division is the opposite of multiplication, but you have to divide 4 on both sides to once again keep the equations equal. So we'll divide 4 here, and we'll divide 4 here, and we'll get x is equal to 2. Now, what we can do with this is, you can put this number back into the original equation, and both sides should equal each other. So if you put 4 times 2 this time, because x is 2, plus 2, this is equal to 8 plus 2, which is equal to 10, which is what the original equation is equal to. So this is the usefulness of two-step equations. You can find out what x is equal to, and then find out how that makes the whole equation equal to each other. Now, I'll give you guys an example, and you guys have to work through it with me, okay?
Yeah.
Okay.
So, we'll take the equation, let's say 3x plus 15 equals 33. And the numbers are a little bigger, but it's the same basic idea. We just need to get the x by itself. But there's so many other numbers there. Whatever shall we do? What do we do?
Well, we could subtract 15 by both numbers.
From both sides, correct. We would subtract 15 from both sides to keep each side equal. So then we get 3x is equal to 18. Now, Michael, what would we do here?
Now we can divide both sides by 3.
Yes, we would divide both sides by 3 because the 3 is multiplied to the x, and you would have to divide the other side by 3 to keep both sides equal. So you divide by 3, and you get that x is equal to 6. And if you plug 6 back into this, you'll get 18 plus 15, which is equal to 33. Exactly. And that's how you solve two-step equations. Now, there's an easy way to remember this, and I've written a simple song for this. So I'll sing it one time slowly, and you guys try joining in the next time. It goes something like this. If you want to solve equations, but you don't know what to say, move over the constants and divide the rest away. So let's go, one more time. If you want to solve equations, but you don't know what to say, move over the constants, divide the rest away. And that's it, that's two-step equations. Yeah, that's it.